1.5. We're going to review what continuity means. Remember, to be continuous at a point, the left-hand limit has to match the right-hand limit, and it has to match the function value. All of those values need to be the same to be continuous. So if we have this example 1 function, we got to determine where the function f of x is continuous and then do some other stuff. So we look at the functions first. A lot of people forget this part, but just look at them. And we notice that this is discontinuous. X can't be -3. There's a vertical asymptote there. Okay, and this one, the domain, is greater than or equal to 0. Whoops. Okay, that's something just to note. We should keep that in the back of our mind as we go through this. Now, anytime you have a piecewise function, you want to look at the values where you jump to the next equation. Is it continuous there, or is there a jump or a hole? All right, so as we take a look, let's try this. What's the limit as x approaches -2 from the left side? In that case, we're looking at this equation. So if you put -2 in there, you get 1. The limit as x approaches -2 from the right side this time. So we're going to be looking at this. Put in -2. You get 1. And f of -2 equals 1 because it equals -2 there. So we are continuous at -2. That one's good. All right, I'm going to clear out my work. Give us a little more room. All right, let's check another value. Let's check 2 this time. Limit as x approaches 2 of f of x. 2 from the left, that's going to be 9. Limit as x approaches 2 from the right side is 4. So f of x is not continuous at x equals 2. Okay, next color. Let's see. Green. Let's try 4. Limit as x approaches 4 of f of x from the left side gives us 16. Limit as x approaches 4 from the right side is 16. And f of 4 is undefined because there's nowhere where it equals 4. So 4, it's also discontinuous there. So we had to determine the values at which the function f of x is continuous. So let's answer the question. F of x is continuous. I'm going to get real fancy. This means that upside down a for all x values, for all real number x values, except at x equals -3, 2, or 4. Okay, now we're going to answer the other part. Limit as x approaches -infinity. Well, negative infinity would occur in this section. So if we let our numbers get really, really big in a negative sense, it's going to approach 0. And then we have limit as x approaches infinity of f of x. This time we're looking at the bottom section. If we let the numbers get really, really big, it's going to continue to get really, really big. Infinity. Continuity on an open interval. If it's continuous at every single point in the interval, then it's continuous on the interval. For an open interval, it's pretty easy. You're just testing everything in the inside. A closed interval, it helps you be more specific to have this laid out. When let's say we're talking about an interval like this, from here all the way to here. The function is continuous if the limit as you approach it from, say, the left side equals the endpoint value, or the right side equals the endpoint value. That's what this is saying. And we'll see that in the example below. All right, so we have Determine the largest interval over which the function is continuous. So in this case, it's continuous from 0 all the way to 1. And it's discontinuous at 1 because the limit as x approaches 1 from the left is not equal to the function value at x equals 1. Okay, I'm going to write that out in math terms. The limit as x approaches 1 from the left is not equal to the function value at 1. Okay, the next place, and the picture kind of makes that apparent, but it's good to have the math behind it. Then we can say it's continuous from 1 to 2, and then also from 2 to 3. Example 3, we have this wonderful looking graph here, graphus interruptus. I think we used that before. So you have that right in front of you. I'm just going to look at the questions. On the interval, x element of negative infinity to infinity. That just means that every single number, okay, all the real numbers, list the largest intervals for which it's continuous. Well, if we go left to right, it's continuous from negative infinity, and it looks like all the way up to -2, where we have an asymptote. And the limit, let me write this over on the side, the limit as x approaches 2 from the right of f of x is infinity. F of 2 is 2. They're not the same, and that's why I have an open interval. Okay, the next part, it would be -2 to 2. We also have 2 to 5 and 11 to infinity. Okay, and 11, notice it has to be open there. So the largest intervals, we're just listing all of them, but these ones technically are larger. Okay, find the largest value of b such that the function is continuous on 5 to b, okay, closed, but not in 5 to b plus 1. So if b is 6, okay, that would say it's continuous on 5 to 6, but not continuous on 5 to 7. And that's true. So b equals 6 works, but that's not the only thing, because it didn't say it had to be an integer. So technically, any value between 5 to 6 would open could work. So we're saying b can be any number between 5 and 6. Technically, it could even be equal to 6. That's what I meant, because I wrote that over here. All right, so if we want all the values, I'm going to clean that up. That looks awful. My dog's trying to distract me right now, so I think it's working. But all values of b that works, it would be anything from 5, not including 5, to 6, including that. Okay, the next part, the largest interval that it's continuous on, well, we could put 8 there, right? It's continuous from 8 to 10. We could put 9 there. So if we wanted to have all the values that a could be, we'll say a it can be anything. We can include 8, because that's the lowest thing that we can include, because then we have a hole there. And all the way up to anything right before 10. The largest interval for a would be a equals 8. The smallest value that on which the function is continuous, it looks like 11. Because right at 11, we have that hole there, so it would be discontinuous at 11. But k would, since we're not including 11, it's fine. And now this one's a little bit different, because we're including that endpoint, and there's a hole there at where x is 11. So we can't have 11, but we could have 12. If it had to be an integer, our answer could be 12. Otherwise, k could be anything greater than 11. And there you go. There's our first video.